Have you ever really thought about what happens when a network admin clicks install policy on a firewall? It feels so instant, right? But behind that one single click, there's this hidden, super high stakes journey that turns a simple rule into the absolute law of the network. So come on, let's pull back the curtain and actually follow that policy step by step. Right, so at its heart, a firewall policy is just a list of rules. Allow this, deny that. Simple enough. But how does that list, sitting on a management server somewhere, get all the way to the front lines, to the actual firewall gateway, and start protecting everything? That's the real mystery we're unpacking here. And this whole incredible journey, from just an idea to actual enforcement, it all kicks off in the simplest way you can imagine, with one single deliberate click. So this first step is called initiation. You've got the administrator, they're working in the GUI, they make a change, double check it, and then they hit the button. That click is literally the starting gun for the policy's race from the central command all the way out to the network's edge. Now, what's so cool about this is that it's not just a simple copy-paste job. Oh no, it is a carefully orchestrated 6-step journey. We just saw initiation, but next it has to go through verification, then conversion, compilation, transfer, and finally, the big one, the commit. This entire structure is built for one reason and one reason only, to make sure nothing, and I mean nothing, goes wrong. Think about it like this. Before you start building a house, you check the blueprint, right? You make sure all the measurements add up? Well, the system does the exact same thing with our new policy. It has to be 100% sure the rules make sense and won't accidentally, break the entire network. And that brings us right to step 2, verification. Before that policy goes anywhere, the system runs a full integrity check on the whole database. It's basically hunting for any problems, conflicting rules, syntax errors, anything that could cause chaos. Because a single bad policy could bring a company to its knees. This is the crucial quality control step that makes sure the blueprint is perfect. Okay, so our policy passed the check, it's solid. But there's a problem. It's still written in a way that's easy for us humans to read. But the firewall itself? It doesn't speak human. So now it needs a translator. And this is where something called inspect language comes into play. You can think of it as this special in-between language. It's not the simple allow/deny that we see on our screen, but it's not the raw machine code yet either. It's a really precise script that lays out every single rule in a way that the firewall's core engine is built to understand. All right, now we get to the real transformation. This is where the magic happens. We've gone from a human-readable plan to a specialized script. The next step is to forge that script into something the hardware can execute in, like, microseconds. And this is that moment, the compilation phase. Just look at this. On the left, you've got that simple rule we can all understand. And on the right, that's what it becomes, compiled in spec code. You can really see the shift from an abstract idea to a super optimized set of commands the gateway can actually enforce on live traffic. So our policy is now this lean, mean enforcement machine. Awesome, but it's still just sitting on the management server. The next big challenge is getting it out to the firewall on the front line, and it absolutely has to get there securely. This, my friends, is the transfer step. The compiled policy gets all packaged up and sent across the network. Now, you can't just send this stuff in the clear. I mean, imagine if someone could intercept that file and change the rules in the middle of the transfer. They could open up a massive security hole. So this whole transfer has to happen over a protected, totally secure channel. So how is it secured? With a framework called SIC, which stands for Secure Internal Communication. This is the tech that builds trust between the management server and the firewall gateway. It uses some heavy-duty encryption and authentication to do two really important things. 1, it keeps the policy secret while it's traveling, and 2, it makes sure the gateway knows for sure that this policy came from the right manager and hasn't been messed with. So, the policy has made it. It survived the whole journey. It was initiated, verified, converted, compiled, and securely transferred. It's arrived at its destination. And now it's time for the final critical moment where it actually takes command of the network. Okay? The package has landed, the gateway has authenticated it, decrypted it, and now it's ready for the big handover. And this has to be perfectly seamless. You can't have a single second of downtime or a gap in protection where the old policy is off and the new one hasn't started yet. And this final step is called the commit phase. This is the moment. The gateway swaps out the old policy for the brand new one. It loads that new rule set into its enforcement engine and, boom, Instantly, it starts inspecting traffic against these new commands. And that's it. Journey complete. The click has officially become command. One new firewall policy is now active, and the security of the entire network has been updated. All of that happened in just a matter of seconds, but it was done through this incredibly robust and secure process. This whole 6-step process is just a masterclass in making sure things are stable and secure. It's designed from the ground up to prevent errors and guarantee integrity, but it's not instantaneous. And that leaves us with a really big question, especially in today's world of rapid-fire everything. Is this methodical, careful process a firewall's greatest strength? Or, in an age where attacks happen in the blink of an eye, could it actually be a weakness?